On the emit from surface node, I'm next going to initialize some values. The first value I'm going to initialize is the frame at which the particles are born. And the second value is going to allow me to determine a birth position for each of the particles in relation to the center pivot of my spherical emitter. This is going to help me later on when I'm trying to calculate the spin for the particles. And all it is a simple calculation of our particle position subtracted from the position of the sphere. So we're just getting an offset to each of the positions on the surface of the polygonal sphere. So to do this, we're going to use some set data nodes. I'll pull in the set data compound, and I'm going to write the attribute on the point cloud on the self object. We're referring to any object that this node is added to. So it's an isop on point cloud. And we'll call it self.born. And I'll execute on emit. And I just need to initialize this value. So I'm going to initialize it with the current time. So that would be the time that the emit from surface is calculated, so the second frame of the simulation. So I'll access a current time and use that to initialize the born value. So I'm going to comment that. So this is the birth time of our particle explosion. And we can use this to modulate size later on, as well as alpha. Just resize this here. It's a little large. There we go. The next attribute that we're going to initialize is our relative position offset from the sphere. So I'm going to again use another set data node. So I can actually just jump in here. I could even right-click, insert a new port, and in the new port just provide a new value. If I double-click, I could call this self, I guess we could call it offset position. And we could get the point position. So if I was to actually get the point position from the getter's deformation or getter's particles, I'll get the point position and subtract it. So I'll look for the subtract node in the math category of tools from the sphere's global position. So if I just press Explorer by pressing 8 and drag the emitter object into my graph, I'll explore the get data that it represents here in the graph for the global point position. So under the emitter, kinematics, I'll pull in its global position there. So I'll subtract the two of them. And we might want to be able to control that position, amplify the offset a little more. So I'm going to go in and give it a little amplify control if I need to tweak those values by driving a multiply by scalar. I almost always use a multiply by scalar if I know I might need to tweak values at some point, offset them, increase amplitude, decrease size. So this really helps. And I'll define that as my offset position. At the moment, we're going to leave our multiply by scalar at a factor of 1. So basically, we're taking the true point positions difference between the emitter and our particle position.